we're looking at the electric potential from multiple charges. And I want to figure out the electric potential at any given point in space from all of the charges that are presented in the configuration. And this is going to be important for us later on to talk about what happens to charged particles if the voltage is changing at any given point in space, and we can make predictions about where charged particles will move towards and what kind of energy those particles will have. So to figure out the voltage at any given point in space, we have to look at the voltage from each individual particle. So to get the total or the net potential, remember this is not potential energy, but this is electric potential, or the voltage, V, for multiple charges. You have to get the potential for each charge on a point, on this given point in space. You must find the potential from each charge on a point in space. Which means, algebraically, that the net potential is equal to each individual potential. So the potential there, net potential, is the potential from this charge, and this charge on that point in space, and that charge on that point of space. Recall that the potential, or the electric potential from a point charge is K Q over R, where Q is that charge that you're examining and R is the distance away from the point in space to that charge. So we can just add up all of our potentials. Oh, and by the way, positive and negative matter, so you're going to need to keep that in each term. So V net is, let's do this business, K Q1, that's the first charge that I'm looking at. That's a positive charge, so I don't need to add a negative in there. The distance away is A. V2, so the second charge on this point in space is K. Well, that's a negative Q2, so I'm going to pull the negative out in front. The distance there is B. And then plus the voltage from 3, I have K Q3. Oh, that's a negative. Pull the negative out in front. The distance is C. Add up all that, and I get the net voltage on that point in space from the 3 charges. Seems simple enough.